All right, so we're going to look at how we can get started in Onshape. Onshape being the 3D modeling tool we use to be able to design our robots and pretty much all of our projects for the last 2 to 3 years or so. We've been using Onshape. There are a variety of CAD programs that work, so you may, if you end up deciding to be a mechanical engineer or a civil engineer or something that's designing physical things, you'll probably use some different CAD packages. Onshape may be one of them. You might go to college and end up using something like SolidWorks or Autodesk Inventor. If you end up getting into like the automotive industry, they have things like CATIA and NX and different things. If you're in aviation or anything like that, there's like different software tools that are specific to certain industries, and certain companies use different ones. But really, as long as you can start understanding kind of the fundamentals of how 3D modeling works and how we're able to design things on a computer, switching from tool to tool isn't really that difficult. Like there's some, you have to find the different buttons, but it's really not that difficult, where it's kind of like using Microsoft Word versus using Google Docs or something like that, where they kind of do the same thing, but the buttons are kind of in a different place. Or maybe one can do something that the other can't, but the main tasks are going to be pretty much the same. The first step in getting Onshape, which I think most people have done, but probably not everybody, but we'll go ahead and talk through that step as well, is to go to onshape4frc.com and to go to the Start Learning Getting Started button here. And this walks you through how to properly create your account. So you have to navigate to the specific education plan page so that you get a education account. That's really important. If you don't have an education account, there's going to be a bunch of files and things in our documents that you can't edit, and it gets really frustrating. So just make sure you set it up with an education plan and you follow these steps. At some point, you can do all the training without this, but at some point you'll need to join our team. So at some point when you're in the lab, you can come and tell me, and I'll let you type in your email address and you'll join our team so you can get access to like our robot files and stuff, and you can edit things that all of the members of the team share. But this is the easiest way to go through. So you can be doing this now if you want, if you haven't already, and you can go ahead and get your account created and linked up. From there, this page is also just really useful information to read anyway. So if you go through this page, it talks about the MKCAD library, which we're going to spend a decent amount of time on in this hour here in a little bit. It also talks about feature scripts, and these are two of the biggest reasons why we choose to actually use Onshape instead of any of those other CAD programs. Because there's a lot of stuff specifically designed or specifically created by different people to make it super easy and fast for us to do some of the tasks that we do a lot in robot designing. And these are part of them, this MKCAD library and these feature scripts, and we'll show a couple of these today. But most of what we're going to talk about feature scripts, we're going to talk about in the next video session on Thursday. The other part down here is it has several different ways that you can start learning Onshape too, and all of these links are pretty good. And we'll talk about a couple other ways that I think might be a little bit better of an intro, but there are times to come back through these and learn a little bit more about how these work. But the learning pathways do a really good job of walking you through. They have little quizzes in there, and you can learn how to use the tool really well and kind of get trained on it. And then a lot of what we're going to do on the team is go through like the education of actually learning to design a robot, and that's the harder part. So the first kind of barrier to being able to do that is being able to use the tool, which is what all this training's for, which can get kind of boring sometimes. Ideally, some of them are better than others, and we're like designing skateboards and things, and some of them are interesting. But eventually we're going to get to the point where we're doing custom design stuff and we're solving problems using Onshape as a tool that we can use to actually design some aspect of the robots we build and tweak and iterate and make the robots we build better because we understand how to use the tool. Okay, so that's Onshape for FRC. It's a very useful website. The other place in it that is useful, if you go to the blog, you can go through, there's several different articles on how to use different parts of Onshape. Some of this we're going to go over next week. But they have several different things on how to use some of the feature scripts and different ways to make Onshape work for us in FRC, which is really cool. Okay, so let's look at Onshape real fast. So this, when you get your account, you'll have your My Onshape, and you'll have the parts that you've made inside your own Onshape if you create documents. But then we'll eventually get the 3847 general folder, which is our team folder. And in here we have several different things. This should actually move to CAD library, so I'm gonna go ahead and do that. And we can go in and we can actually see what a full robot looks like real fast, so you can kind of see what the end goal is. So we can sort everything by name, and we'll have infrared. So this is the full infrared robot in Onshape. And so this is done by linking several other documents together. So we have each like individual part. So the drivetrain, the intake, the ball path, the part that like stores the balls and moves it to the launcher, and the climber. They're all in their own documents. And we have a few other things that help us make the robot. But we'll eventually, over a lot of hours and a lot of time and multiple people, be able to get to a full robot. It does take a little while to render the whole robot. But Onshape allows us to very easily, compared to a lot of the other ways we've done it in the past, collaborate. We're going to have different people working on each of those different parts of the robot. We can have individual people come in and do like a single part of something, and make it so that the robot looks very, very similar to the robot you all have seen in the lab that actually does the work. We can go in and like see each individual plate. Things should actually be able to move, so I can actually move the intake up and down. And so we can see a lot of those parts. So there's some things that aren't quite right. So like this bar is just floating in midair because it's missing the one that goes over there. So there's a lot of things that may have happened later in the season where we're trying to get stuff made quickly. Not everything's perfectly done in CAD, but a lot of it's pretty close so that we can at least keep designing, and we can keep modifying things that we need to get the robot working well and continuing to do what we need to. So yeah, so we can change all the colors. We can get an approximate weight. So before we ever actually build anything in a season that's going to be on the actual competition robot, we can know a lot about how this robot's going to fit together, how things are going to work, before we actually get to building it. And so we know everything's going to work when we actually build it. So we're not just like guessing. We can do all the design virtually, make all the changes really quickly, and produce a high quality robot at the end. That's the goal. Okay, so a couple other things that we can look at. So what do I want to do? So we have this document here, which is our Onshape kind of training challenges. So as you're going through and you're deciding you want to learn Onshape and you want to learn to use the tool, this has a list of different things you can start doing as you're learning how to do it. And you can start going through these and being like, okay, how comfortable am I doing this part of a robot? As you go through these steps, you should get more and more comfortable with Onshape, and you can do more and more. This skateboard tutorial, which we've had several students do already, is definitely the place that I think is the best to start. There's a couple little oddities in there that you may have a question or two about. Again, feel free to ask me or any of the people who've done Onshape for a little bit, and we can try to help. But mostly it's going to take you through designing this skateboard pretty well, and it goes basically step by step. And if you can get through this whole thing, you can do a lot of what it takes to make an actual mechanism, or at least a part for the competition robot. Most of these steps are very similar, and it walks through very nicely how we organize things, how we go in and actually start creating some of these parts. So you can click and make it bigger, and it'll walk you through how to actually make the skateboard deck in each of these different shapes. It like shows you how it's actually being done, which buttons to press, which tools to work through, and it does a pretty good job. So this isn't a full video version, so this is like you're just watching the animations and reading the text. If you prefer the full videos, those exist too, especially in places like the actual Learning pathways, these have a lot more very specific details, so if you'd rather have more in depth and you don't just want to kind of go through it and get through the training this way, the learning pathways down here do a really good job. They just take longer. So if you did all 9 of these, this is probably going to take you 6 to 9 hours maybe, depending on how quickly you go through them, where the entire skateboard is probably like 3 to 4 if you did all of it. And that's definitely a good way. This also goes through a bunch of the keyboard shortcuts and just really goes through a lot of the things you need to know to be able to actually do a lot of to be able to actually start using Onshape to make stuff. And that's really what we want to be able to do. So once you're comfortable enough to start making things, we can start, if there's something that you want to make and we can 3D print it, or if you want to design something, we can laser cut it. All of those things are made possible by being able to design in Onshape. So that's kind of the goal of why we emphasize doing the Onshape trainings, is because most of the other stuff we do all builds on being able to do some amount of modeling in Onshape and creating something there that we can then 3D print or laser cut or work on the CNC router or even on the lathe and things. We normally still design it in Onshape and then figure out exactly what size it needs to be and everything else, and then we make it manually if we need to. Okay. So yeah, so this goes through a lot of the actual sketching and things. Let me make a new document back here so we can see how some of this base tests work. So when we create an Onshape document, it kind of brings us into this 3D space where it's just like this empty world. We have these 3 planes. These aren't actually exist. These just allow us to have places we can draw. And we can move it around. So if we click our right mouse button, we can rotate the world. If we click our middle mouse button, we can drag the world around. And then we can basically create anything we want inside of this space. So this is called a part studio. So this is where we actually create the individual parts. The other option we use a lot is called an assembly, and so this is where we put different parts together and tell them exactly how they're going to interact. So if we want them to move in a certain way next to each other, things, if we want them to pivot or rotate or slide, we do all of that in our assembly. But a part studio creates each type of part that we're going to use. If we're going to have multiple of them, say we're going to create a wheel, but our robot actually has 4 wheels, we would have duplicates of those in the assembly, but we'd only create 1 wheel in the part studio. So that's useful to know. Is basically in the part studio, we only want 1 of anything. So if you're gonna have the same thing, there should only be 1 of it in the part studio, and then multiple in the assembly. So how do we actually make stuff? So as we go through the tutorials, you'll see it, and a lot of you probably have already done it, but I'll go through it quickly. We can choose which sort of plane we want to be on. So I'm going to look at doing something from like the top down. So I'm going to click on the top plane. This cube over here lets you navigate and kind of like rotate to a specific orientation really quickly. So if I want to look down from the top, I can just click the top button there. And then we could draw a circle. So all of the sketch tools are similar to any sketching program or painting program. The big difference with CAD is we're a lot more interested in the exact dimensions of things. So you can see as just as I start drawing the circle, we get those numbers next to it, and it's telling me how many inches the circle is. And I can actually, as soon as I click off, I can just start typing, so I can tell it I want it to be a 3-inch circle. It'll let me do that, and I can hit enter. And now it's fully defined as a 3-inch circle. So I can't, hit escape, I can get back to just my normal cursor. I can't drag this and make it any bigger or anything like that because it is, it has this dimension here where it's set as 3 inches. So that's one of the biggest things that CAD tools do compared to just normal drawing tools or anything, is we're very, very always worried about what it's going to look like in real life. So we're setting everything to real dimensions. We're making sure things are defined in relation to other things. So I can't, because I drew this right on the origin, so that's a point in space that kind of exists and it's locked there, I can't just drag the circle around. If I draw a different circle, I can click the center and I can move it around. I could click this outside and I can make it bigger or smaller because I haven't fully defined it anywhere yet. So we don't like these in our robots very much. So if we're designing some part for the robot, we don't want a lot of these blue circles hanging around or blue shapes, because then if we move something else, who knows where that shape's going to be, what size it's going to be, or anything. Everything could change, and we don't want that. So almost all the time when we're designing robots, we want everything that we're sketching to be fully black, because that means it's fully defined. It means I can't change its position or its shape. And so when we actually go to 3D print it or laser cut it or anything else, it's going to be the exact same every time we do it. No matter who comes in and moves some lines or clicks something weird or anything like that. Okay, so I'm going to delete that one, and I'm actually going to add a different one back in that middle so we can make a little ring. Make that one be like 1.5. Okay, so I have this 2D thing, and I can spin it around, but it doesn't have any depth. So this is just a sketch because this is just 2D. If I want to make it 3D, I have to use some sort of feature. So we have a bunch of different features we can use. The one we use the most is extrude, and this lets us tell it which part we want to just like make thicker. So I can click on this outer ring, and I can make it a certain thickness that way. You can also click on the inner ring, so I can make the whole loop there. You can click on just the inner part. So anything that is just a closed section of the sketch, right? So it has the 2 circles, there's no like line breaks or anything, it's a fully closed shape. You can do different extrudes on if you want. So I'm gonna go ahead and make that ring. It's gonna set it at 1 inch. If I wanted to change it, I could. You can actually like drag this arrow. We normally don't do that very often. We normally just type what number we want in here. So maybe I want it to be 2 inches. And so that sets the exact thickness that this part is now. A couple very useful things that Onshape lets you do is measuring things is super easy in Onshape. If you just click on one face, if I want to know how far it is from this other one, if you just look down in the bottom right, you can see it says that it's already 2 inches. If you click the little measuring tool here, it gives you a lot more numbers. These ones are all basically the same because that face is always 2 inches. But you could click something else. I could go from like the origin to this outer ring, and it's going to be a little bit different shape, right? So I have this like 2.136, because that's the line it actually draws from that ring to that point. But it can give me individual dimensions, so you can see like, and it kind of draws it on the screen. So I know the red line is 0.75 and the blue line is 2 inches. So this is really useful if we're just trying to figure out how big something is, some part of the robot that we just need to measure real fast to figure out what we need to make, or how big some piece is going to be so we can put it on the laser cutter. Anything like that, being able to measure quickly is very helpful. So this is even if you don't necessarily know how to fully design a robot, you can still use Onshape to help you in helping build the robot or maintain the robot or test the robot or whatever we're doing. Even if we're not one of the main people designing the robot, Onshape is still super powerful in being able to look at it, diagnose what's happening with the robot, create something, anything like that. Okay, what other parts of this make sense? So eventually these planes kind of get in the way, so we can hide them. So you can click and you can hide different parts of things. Say maybe we wanted that sketch back, so you can actually unhide the sketch that exists. Over here on the left, this is called our feature tree. And we can hide and show different parts of this depending on what we're doing. We may need to like hide the part because we're looking to do something else with the sketch. And so we could go in and unhide or hide the part. Similarly, we could use the sketch for different things. So if I wanted to come in, I could actually do another extrude. And I could add it to like the back side. So I could actually add to the part that we already created. But one of the powerful things about Onshape is in this same part studio, you can create multiple parts. So a lot of times when we're building the robot, we'll have a dozen or more parts all built into the same part studio because they're all kind of designed in relation to each other. So they might all be designed off the same sketch. and we'll create a lot of different parts based on that. So instead of add, if I go to new, it'll create a different part. So you can see it down here, it says part 2. And so now these two parts are separate, and the only difference is whether I say add or new. The other thing is you can actually remove. So if I go to remove, I can flip the dimension with this little arrow, and it'll cut away some part of it. So depending on what I'm trying to do, you might need to cut something. So if I add, let's see, so yeah, so I can add this in. And so now we have this like little bottom section there. I can now hide the sketch. And this whole thing is just one complete part now, because each feature just adds to that part. So you can go even further. You can make little details. So say we don't want these like sharp edges. We can fillet them, which is to like round the edge. So maybe I want to round this outside edge, make it less sharp. You can set the exact dimension of how you want to round it, maybe like 1/4. And then you can also chamfer, which is like cut it off kind of at a straight edge. A lot of times we'll do this for 3D printing, so it makes the printed parts easier to have certain sizes and things. So we can go in and make a small chamfer at the bottom. If I can type, so we can make that 1/8 of an inch. I happen to know that 0.125 was 1/8, but if I wanted to just use 1/8, Onshape will do all the math for you too. So you can do 1 divided by 8, and that's totally fine. Onshape knows what that means. You can also do addition and subtraction, multiplication, anything else like that in there too. So if there's times where you need to divide by 2, multiply, you don't have to like bring out a calculator or anything. Onshape will do it, and the nice thing is it will stay that way. So when I click in here, it'll show me what like the formula is that I use. So you can do a lot of like specific, you can leave the intent of what you actually meant in here. So sometimes you can do 0.5 divided by 4 because you want 1/4 of a half an inch for some reason. And there's some where you might end up needing to change that later. And you could still do that and get the right number, and kind of leaves that equation there for you. So something like this, if we needed this, I don't know why we would need this part. I don't know what this part would be good for. But if we wanted to, we could 3D print this from here. And we'd be able to have this part, if I put it on the printer tonight, we'd have it tomorrow. So there's all sorts of things we can do, and it's really powerful to be able to quickly sketch something up and be able to have it created basically from your imagination to fit whatever need that you have. You can go in there and do really, really quickly. Okay, so let's look at how MKCAD works really fast. So we talked about how part studios are designed for like creating things, and as you go through those tutorials, especially like the skateboard tutorial, you'll make a bunch of different parts, and you'll eventually get into assemblies where you start actually putting it all together. So you go in and you'll create the deck, you'll create all these individual parts, and then the assembly, you'll actually mate them all together, which is really cool. But for this thing, you had to actually create each of those components. Since a lot of the times in the first robotics competition that we participate in, there are a lot of parts that we just purchase, right? So some company designs them, they produce them, and we just buy them. So we don't have to create the CAD file for all of those because they already exist. They just, you can download them from the company's websites, which does work, but it takes a little bit of time to go find it, get it actually imported into Onshape, and all of that. So what we have now is called MKCAD. So the MKCAD app adds this little button over here on the right side of the screen, this little blue MK. And when we pull this up, it lets us see a whole bunch of different part categories for all the different things that, a lot of the common components that you can buy for first robotics competition. So we don't use all of these parts, but there are a bunch of different ones that we do. And so we can go in and see which ones we need sometimes and grab just those. So I have some that, logged in not as my normal account, I'm logged in as the team account, so I don't have favorites in here currently. Let's see. So a lot of times we have motors that we use on our robot. So we have the Falcon. And so we use the Falcon 500 motor a decent amount. And so I can go ahead and insert the Falcon 500 motor. And when I click on that, it comes in. And so now I have the entire model of this Falcon here without me having to go to the website, download it, or anything like that. Similarly, if I had like the pulley for a Falcon, so these are the pulleys that we actually use quite a bit on our robots. It actually put it inside of it, so everything gets placed right on the origin. So it's a little bit weird. So sometimes things get put inside the motors or anything, so you do have to find them. You can see that it's up here. So I now have this pulley, I have this motor, and I didn't have to model anything, but now I want to have the pulley actually on the motor shaft. So to do that, we're going to use mates. So these buttons up here are all different types of mates, and these basically just define how the how one part can move in relation to the other. The most common mate by far is called fastened, and that just means these two things are connected together and they don't move in relation to each other. So they can't slide or spin or anything else. If you move one, you move the other, and they stay basically locked together. So I'm going to use fastened here. And I'm just going to come in and I'm going to kind of hover over the end of this pulley. And that little red, green, and blue thing in the center there is what I'm kind of looking out for. And it's going to tell me where the mate connector that I'm using is. So that's what that little red, blue, and green thing with the little orangish circle around it. That's called a mate connector, and that lets us know where we're going to place this in relation to whatever we're going to attach it to. So in this case, I'm attaching it right here to the end of this pulley. And I can come in and I can tell it to do the same thing onto this onto the motor. So it's a little bit weird to get the exact right spot because I actually want it to be roughly in that kind of like middle white spot down there, and it doesn't always work. So sometimes you can see it's trying to put it all in these weird places, and those aren't the places I want it to be. But sometimes it is the place I want it to be. I'm trying to figure out if I can actually show you. I happen to know where it's going, but it doesn't always let me do it. So there, so when I have it highlighted just there, it shows the mate connector where I want it, because this is basically drawing it as a full circle. I moved, so I have to get it back there. Okay, so now it's back where I want it, and it's down in the center of the shaft, and if I click there, it's gonna move the pulley to that spot, and we can see it's attached where I want it. So if I hit the green check mark, now that pulley's down on that shaft where I need it to be. It's a little bit weird here because it's not lined up. So these little teeth should be in line with the pulley teeth there if we were doing it in real life. In CAD, this probably doesn't matter. We know the pulley's on the shaft. That's what we want. Oh, I messed something up. Sorry. Let's undo what just happened. Yeah, there it goes. Okay. I tried to, it tried to like fasten something I didn't actually want it to. So we could go in and try to rotate this and make it look exactly correct. Most of the time we won't care. As long as this pulley is here, we know the shaft's gonna be right in the real robot. It's not a big deal to change. If we wanted to, we could look straight on this and see if we can get those to line up. So you can do cardinal directions this way. Yeah, so that immediately, so just changing that 90 degrees got it pretty close to correct. So now that little spline tooth is inside that tooth, and that's how it would work on the real robot. And so we could go in and we could put spacers or a bolt in here to retain it, or anything like that if we wanted to. But now that they have this fastened mate, I can drag this motor around and the pulley comes with it. If I wanted to, I could tell the motor to be a certain position, so I could like tell it to be mounted to the origin, in a certain way. Maybe I can tell. There it goes. So yeah, so it'll mount to the origin. And now I can't move anything because the motor is fastened to the origin and the pulley is fastened to the motor. And so you can build really big assemblies doing this. You can mount all the parts together. So a lot of times you end up mounting things just like you would in real life. So you just fasten like the bolt hole for the motor to something else. Let's see, we have some examples here. That's a weird one. Let's use one of the Versa motor mount ones. Maybe not. Yeah, so MKCAD doesn't have everything. Oh, this is actually what I wanted. So we have like this motor plate. So maybe this was how we're going to mount this motor to some part of our robot. And we could fasten this plate to one of these screw holes. And so we fastened one of them. Oh, so we fastened, that's not quite what I wanted. Hold on, let's see. Yeah, so that's gonna be really weird. So let's not actually fasten that. So let's actually go ahead and call it a revolute. So revolute is this one right here. And revolute means that we can have it spin. So I can drag this and it's gonna spin just like it would in real life. So if I had a bolt just going through the plate into the motor, I can move this around, get this kind of lined up, and then you can see I have this other bolt hole here that's lined up. So I could fasten mate those together. Let me make sure those are on the right side. So I want it right at the end there and right at the end here. And I think that should work. Yep, did that do what I want? Yeah, I think it did. Let's see. So everything shifts up. Yeah, so I have something where I could easily put a bolt through here and through there, and I'd be ready to figure out how to mount this whole thing to our robot, which is what we want, without having to do any actual part creation. If this is all stuff that we're just buying, we could very easily do this. If there's parts that we do want to insert, so say I have this part recreated, again, this is not anything super useful, but I can insert that part. So I can insert part 1 into here, and we could figure out how it worked if this was some other size or something, if it went around the motor or on the shaft, whatever it was doing. You could use the part you made. You can rename parts you made, so we could name this whatever, Alan's part. You can change its color, so you can edit appearance. We can make it purple. You can even tell it what type of material it's made out of. So maybe we were going to print this out of like PLA. So that's what normally our 3D printed stuff's made out of. And so with that, we could actually find out how much it weighs. So we can go in and know if we printed this fully solid, just like this, how big it is. It would weigh 0.789 pounds if it was fully solid. And so you can get a pretty good estimate of like how much the whole robot weighs if we make it like that. You can see it updates, so it gave us the color here. So all of those things can be done pretty easily. We have some broken mates for some reason. Let's see. Oh, because that was, I know why. Okay, so we're going to edit this and make this one also revolute, so it's no longer broken. All right, so now this can move around, or so this plate is now bolted correctly. None of it's red. We don't have any errors. We never want to have like red stuff over here because that tells us something's not solving correctly. Like we have two mates that are in conflict. If we were to tell like this hole to also be mated to that hole, it's not something that it can do. So it basically just gives us an error, makes it red and says you can't do it. If we want to go even further, you can go in and do insert. Instead of inserting a part we made or a part from another document, you can insert standard content, which for most of what we do is just inserting bolts and nuts and things. So we can tell it we want a 1032 bolt. We can tell it we want it to be, let's say, 1/2 inch long. And then if we click on the edge of that face, or the edge of that hole and the edge of that hole, we can then hit insert, and it'll put 2 bolts there for us. So we have those bolts already lined up. I'm gonna hide all the mate connectors. And so now we have bolts there ready to go. So we can get a little bit more detail into our CAD just by inserting bolts. This helps especially if we're gonna make sure that we're not having bolts run into something on the robot, or if they don't make sure they don't get in the way. We make sure we know exactly what size and length bolt we need. So it's super useful to have that ready to go without having to like find it or anything else. Let's see. What other parts of this are interesting? So most of all the stuff that we buy is in MKCAD already. Sometimes we have a few things that we use on our team that aren't in MKCAD, so we have a CAD library folder for that. So these are all parts that we might reuse from robot to robot. So we've done a couple of modifications to our the swerve modules, mostly just in CAD, just to make sure that the CAD works for us. A few things that might be new that haven't gotten put into MKCAD yet. Some specific things that we use, like our roller hub that we use on all the rollers. These are specifically designed for us that we print, that we can go in and make. So a lot of things like that we'll go in and make and have them be ready to be reused from year to year if we need to. Same with some different hardware things, some star nuts, various things that we might need to use on the robot for different applications that we didn't already see in MKCAD, so we make sure it's all in here. So if we end up reusing it, we have it already. All the electronics and things for the robot are built in, so we've already have those CADs are either in MKCAD or we have them here for us. So like the PDH and the RoboRio, things like that. We have those built up so that we can use those in our CAD models super quickly. And so that's how we're able to get a lot of this full robot done, to where we have the PDH down there, we have the RoboRio over on this side, I think. Yes, we have the RoboRio there. And some of these are slightly different models than we're using here. We actually probably should update some of these back to the slightly better ones. I don't remember when we did this, but yeah, so they have all some of the information about what goes where, the exact size of things, anything like that as we are building out the robot. We have a bunch of this stuff already done for us. So the batteries, the swerves, all of the things that we buy, most of the time a lot of the time it's already CAD'ed. And then most things we're gonna do is the parts that we're gonna make either on our laser cutter or on a 3D printer, we're gonna make sure we can go in and CAD all of that. Let's look at what one of the actual mechanisms looks like, so you can see kind of what the end goal is. So the launcher itself has an assembly that just has the launcher parts in it. So this is the launcher. It is all of the individual kind of launcher parts. I think something's hidden somewhere in here. Yeah, because it's missing that side plate on this side. Don't know why it's missing that plate. Let's see. There it goes. Okay. So yeah, so if we show that back, okay, so this is basically the entire launcher for infrared. And we can go in, and there's multiple part studios that kind of design a lot of these parts. So we can see some of the individual pieces here. Again, kind of like what I mentioned earlier, a lot of times it'll look a little weird because you're basically only designing like the left side of something, because all of these parts are going to be mirrored and used on the right side too. So we pretty much only have these left sides, and then we go in the assembly and actually put everything together the way we need to. So a lot of those parts aren't designed in that part studio. So like all these pulleys, I said that we already have those in the COTS library. A lot of these wheels, the motors, the limelight, all of this stuff gets put into the assembly. And the only thing that's in the part studio is all of these custom parts, and these are all the things that we actually make in our lab. So we go through and we make all of these parts and create them. So they are here in the actual part studio. So we could go through and you could go through and edit each one of these if we want, and we could see exactly what like the sketch looks like for it. So if I edit this sketch, it's going to back up a little bit and take away a bunch of these other parts, and we'll kind of see what the sketch looks like. So this was the main sketch for the entire side of the launcher, the first part of it. Before we went in, we did like cutouts or anything. This was just how it was originally designed. Make sure it has all of these different holes in it, things like that. All of that, when we actually do the main competition robot, it's all designed kind of off of these original sketches where we design sort of the layout for the whole robot. So that's what this one is. So this derived sketch here, everything in orange, is kind of our base sketch for all of our, I'm gonna hide all the parts. Okay, so we can kind of see here. So all of this, where we have like, these are just super quick things that show like where the bumpers are. This is one, these are both the swerve wheels. And this is just showing where the ball's gonna come up, how it's gonna actually power through and go through the launcher wheels and the back rollers. I think this is like one of the climbing bars or something. So a lot of things are just laid out in these like really quick 2D versions. And then as we get more and more detailed, we get finally to where we actually have all of the things that look like our production parts. And we get the full assembly of a mechanism that gets to what we actually build. So let's make sure we have all of the right belts in place, so we figure out how long they are, what each of the pulleys are, the gears, spacers. All of that's done in CAD, so we know everything's going to be correct when we build it, or that's the hope at least. Yeah, so they go through and they pull the different, they made the different gears and pulleys. Yeah, several more of these different like gears and pulleys that we created. So all of those are done in here. Yeah, small assemblies for the launcher gears and or pulleys and everything, each roller. So all of that can get created and made and then reinserted into the main assembly, so everything can get built up, copies of it can get made, all of that. Kind of as we were iterating things, we like added some hard stops. So this got CAD'd in its own part studio. One of the things we'll look at more next week is what's called in context. So a lot of times when we're CADing this, we don't know exactly like where these holes are going to be if we're just like in this blank space. So we have the ability to kind of draw on our actual assembly that we have made. So once we've been able to do enough stuff to where we have a full assembly, we can start creating stuff, what's called in context. So it just means it's in context to the assembly. So you're using the different holes or parts or anything to be able to sketch your new part based on the assembly. So I'm going to have that load up right now. This has this little assembly context up here. You can actually have different contexts. So if you have multiple assemblies you're basing it off of, or maybe they're in different positions, you can do that. Most of the time, normally we only just use one. But this allowed us to go in and get like, to use these holes from this tube that already existed, allowed us to figure out exactly where this hole should be so that we could make sure the part that we were going to put on here rested on here correctly. So if we actually edit this sketch, we can see what we did to design this was to sketch over these holes, come up here. We knew we were going to have a 1/2 inch little spacer here that was going to mount there, so we sketched it to where it was 1/2 inch and it was intersecting here. We told it how big we wanted that hole, how far away we wanted it from the plate, and it basically allowed us to make this part in a relatively quick manner, just doing all the sketches, and then filleting all the edges to give us nice round edges, and we could go and laser cut it. So this probably took 10 minutes to make, since all it was just drawing out this shape, and we already had all the context around it that we needed, so we didn't have to like figure out all those exact dimensions or anything else. We already had all of this CAD'd for us, so making little add-on parts is relatively easy if it just has to be something where it has a few holes and we kind of know what it needs to do. Okay, and then this same part can get back and added into our assembly. I don't actually know if it, yeah, so it got back added into the assembly here. And so it's in that main assembly now. I don't think it's on both sides, which is probably at some point an issue. Doesn't really affect anything if it's not perfectly in CAD. Again, this was something that got added mid-season, so we had already like built the launcher, and this was a modification we added to the launcher. So it doesn't always get mirrored over or inserted over again. But ideally, we'd want to keep it as close to the real version as possible, so when we make the next change, we have an idea of what it's gonna work, and it's not gonna interfere with anything or mess anything up as we're building the next version of whatever it is. Okay, was there anything else? Oh, there's the last thing. Okay, so yeah, so going through, kind of recapping where we went through. So that was just an intro of what we were able to do with Onshape. Again, my current recommendation is to go through the skateboard tutorial first. That's the most useful use of time, I think. And if you like that way of teaching, it's definitely nice. If you want a little bit more in depth, the getting started, learning pathways, you'll learn a ton. There's definitely a bunch more details in here that are useful that you'll kind of have to pick up along the way if you don't go through them. But if you do want to go through them, they're also very helpful if you have time, especially on certain ones where you're like, oh, I don't quite understand how to use assemblies from the skateboard. You can go in here and just do the Onshape assemblies learning pathway and learn how to do all the mates and everything else in there. So if there's any part of like the skateboard that's not clicking, if it's not making sense, going through and doing the learning pathway for it is a really good way to get that, get a little bit more in depth and kind of make sure you solidify your understanding of how the tool works. The rest of this document has a bunch of different little quick sketches that you can take and then create into a 3D part. So part of this is to help, a lot of this is practice in spatial reasoning, so you can see how a certain thing is dimensioned, what it looks like from the different views. So this is like looking at it just from this side view, this is looking at it from the front view, this is looking at it from the top-down view, and being able to take these dimensions and actually create the part. Because if you can strengthen your spatial reasoning and kind of your ability to view things in 3D in your head, move them around, make sure you can see from different orientations and kind of simulate how a part's going to work in your mind, it helps a lot when you're going through and actually doing the CAD process, and as we do the entire design and development process for the robot or for any of our projects. So that's what a lot of these examples are for. This first section is pretty much just sketches, extrudes, fillets, kind of making individual parts as you go. Some of them get more complicated than others. The goal here is to kind of use as few features as you can. So if you can do things in 2 or 3 sketches and 2 or 3 extrudes, that's better than doing them in 9 sketches and 9 extrudes. So if you have the same, like 2 holes here, you wouldn't want to sketch and extrude one and then sketch and extrude the other. You would just do both of these as the same sketch and then extrude them or cut them out, remove them at the same time. We do want to try to be relatively efficient and keep our feature trees kind of short. You don't want to take it to the extreme though. You don't want to try to do everything in a single sketch. That's not helpful. Like each side of a part, something like that, and you can, as you do it, you'll kind of figure out how things get organized and what makes sense. There's a few little easy things, so going through and like creating a board game piece, then we can 3D print them if you want, or if any of these things, if you want to 3D print some version of it, that's totally fine. We can pretty much print most things whenever you want, if you've CAD'd it especially. And then from there we go into a little bit more in depth into things that take a little bit more time, a little bit more, some specific robot related things that aren't quite as simple as the other ones. And again, you don't have to do all of these. I put in a lot of practice because some people are going to find certain ones interesting and some people aren't going to like others. So feel free to skip around if you want. I just really wanted to have a lot of different examples, as much as we could. And then some of these other ones have some assembly things. There's some work to do on making a little Lego minifig that you can customize. I went through and got all the accessories and parts and stuff done for that into CAD. Some things that have multiple parts, so you're designing multiple parts and putting them together. There's a variety of things that you can do. Drawings are helpful. You can definitely spend a little bit of time on making drawings. We definitely need them, and we use them when we make a lot of the lathe parts specifically, when we have to detail out exactly what the manufactured lathe part's going to look like. And then we get further into things like feature scripts and some actual robot tutorials. So if you want to go all the way into how to do full intake designs, gearbox designs, there's a lot of things you can do that get a lot closer to like the full robot mechanisms and stuff too. So if you're just like, no, I don't want to make these parts anymore, I want to jump ahead, feel free to look through. You definitely want to do some of the part stuff, or at least have done the skateboard before you get all the way down here. But if you end up jumping ahead and you'd rather jump ahead and then ask questions, whatever works for you, however you want to learn, we're pretty easy to adapt to as much as we can. Yeah, we'll get through this stuff a little bit later when we talk about how we organize our full robot and how we go about, there's a lot of little intricacies into that. But most of the 1 through 6, you could definitely do any part of it whenever you want. All of next week is a really good time to do that. After we come back from NTX, I'll be out of the country for all of next week and into the week after. So putting a little bit of time into learning Onshape is a good place to use some of your time. And then this goes even further into some more advanced stuff. So if you want to get into like how to actually render and make the robot look really cool, there's other tools on how to do that. This is something that we've never really done well as a team. So if this is something you're interested in, feel free to go through the video, learn how to do it. And you can gladly render our old robots or render our competition robot for next year. And we'll use it in all of our Judd stuff. We can print it up as a big poster. Anything like that, we would love to do. And then there's a ton more examples down here at the bottom. Feel free to play with them if you like. But there's a ton of work you can be doing to learn Onshape and kind of just get a better understanding of how to use Onshape to create stuff. And then we'll, as we come back from into later October, we'll have more projects. We'll actually be able to design some things, print them, CAD some parts for like prototypes that we'll build to start prepping for the next season when we get the brand new game. And then we have to figure out how to play whatever it's going to be, whatever game piece it is, like all of that. So if we can have the ability to make individual parts, create assemblies, it'll be a lot easier once we start going into how the robots fully work and how we actually design them, for you to be able to jump in and start helping do a lot of those things. Okay, I think that's all I have for tonight.